Right, let's go. Correct. Number one. All right, it's up. Right, all I want to know was the gradient. Whoever correct hand the marker to coming up. So, what is the gradient of displacement time graph? Right. Yes, right here. Right here. It's so hard, my boy. It's such a strong off. Anybody else? Anybody else? Alex, come forward. Alex, what is yours? Alex, up. Yeah, Anita. Right ingredient of velocity time graph. I'm bringing that for Alex after. It was online last week. It wasn't online last week. But you should know this today. What is velocity divided by time? Area under the graph. Anybody else? Area under the graph. Right, so remember last day we focused on time graph, right? And we said for displacement time graph, its gradient is velocity. For a velocity time graph, we said that its gradient is acceleration. Right? Distance traveled. Nice. Now, here what here. Give it to whoever you want. Right here, I given you a displacement time graph. I want to know what the horizontal part represents. Right? So it's something horizontal and a displacement time graph. I want to know who it represents. Any Nathan, one only come. What does the horizontal part on a displacement time graph represent? All right, B is 0, so but I prefer to write stationary. Right, to take off the question mark and put stationary.
Above B is stationary.
Get for stationary. So on a displacement time graph, if you see a horizontal line, it means stationary. Right there, right there. Yes. No, destiny. Right. Last one. What does this mean? A velocity time graph. What does the horizontal line mean? Acceleration is what? 0. Right? Yeah, come on, right up. Acceleration is 0. Acceleration is 0. So the object moving, but it has an acceleration of 0. Right. So we're gonna use back these things now in some past papers, right? So once you see these things on graphs, I want you to remember it, right? If you see a displacement time graph, the gradient is velocity. If it's a distance time graph, the gradient is speed. All right. Anybody remember the difference between velocity and speed? One is a what? Right. One is a scalar, one is a vector. All right. One is a scalar and one is a vector. Right? We did 1 year last week. 1 or 2. Do I give you a hard one? I give you a hard one. I'll give you the root of it. Fine. Good. Just create it. All right, so let's take a look at this here. And here online there. So here's a speed time graph. So before we start working it out, right? You have to know the three things that are important on speed time graphs: gradient, acceleration, area under the graph, distance traveled. Okay? So you're focusing on 5, 3, and 2. Okay? Take a look at it. Again, it's in the group. It's topic by topic, page 114. Right? For those who can't see, topic by topic, page 114, or you can take a pick of it, right? Take a look, click and do me. Giving you a few minutes, right? I'm giving you a few minutes. Take a look at it. Try to work it out based on the information, right? One, four. Right, but you can take a thing, right? All the info you need is number 2, number 3, number 5. But page 114. Page 114. Right, if you can't see this, if you can't see, just take a pic and zoom in, right? Page 114. Please take up on the headphones, please. Right? So again, remember the type of graph, right? Remember the type of graph, right? It's a speed time graph. So you're using all your rules for speed time graphs. So during the first stage of the journey, the car increases speed from 0 to 12. You're saying that? From 0 to 12, it went in a nice constant velocity. And then in x seconds, it accelerated at 0.6, right? How we get x? How do we get acceleration on a speed time graph? Acceleration is gradient. So if you find gradient of the first stage, the answer is what? What's the answer? If you find the gradient of the first stage, the answer is what? The question gave you the acceleration already. Right, yeah. So they hold on. So the question asked to find x, that's to find here. Right? And they said that the acceleration, right? The acceleration is the value here is 0.6 ms minus 2. So in this question, you have to work in reverse. They gave you the gradient already. Right? They gave you the gradient. So y is equal to gradient is what? Gradient is x2 minus x1 over, oh gosh, sorry, there was y2 minus y1 over x2 minus x2. Right, and we know the answer. We know the answer is 0.6. Right? So what are the 2 points we're going to use? Joseph, you can ask me. What are the 2 points of the line are we going to use? Close it. What we're going to use here, that point is what? That point is 0, 0, and we're going to use up here. That point there is what? X 12. Right? This question you have to work in reverse. They already gave you the gradient. Right? You have to work in reverse and find best. Okay? So the 2 points that we're using are down at the bottom there, 0, 0, and on top is x12. Okay? Plug in those 2 points into the gradient and solve for x. Are you okay with that? So the question gave you the acceleration earlier. That's okay? The question already gave you the acceleration. So they gave you what the gradient is. Hurry up. Plug it in. Plug it in, and I want to see you solve for x. Yeah? How we solve 2 fractions again? 2 fractions kept by equal sign. What here's 2. Yeah, right, so you'll end up with 2 fractions, cross multiply and solve, right? Right, remember you have y2 on top here, x2 on top there, and you have x1, y1. So y2 is 12, y1 is 0, x2 is x, and x1 is also 0. So we have 0.6 on 1 is equal to 12 on x. What is do again? 30, 2 fractions equal sign. What is do? Cross multiply, right? So you'll get 0.6 by x is 12. X is equal to 12 divided by 0.6. How much is that? How much? How much? 20. What's the unit? Time, right? So it's seconds. 20 seconds. Right? Read part 2, and I will pick on the pick on, the pick on. I'll pick up Jaden. Read part two, Jaden, and tell me what you think the answer is. That's not, I'll give you a little bit. Right, but listen to Jaden. What is the gradient of the graph during the second stage? Right, gradient is 0. What does that mean? At a constant speed, no acceleration. So watch it here. You'll see it here. Same thing in number 5. Right, the gradient there is 0. Gradient is 0, and the car has no acceleration with constant velocity. Are you okay with that? And work out part 3. How we doing part 3? The big one, the big. Who? Israel, part 3. How we getting the distance travel? Right, area under the graph. Very good. Right, Israel said area under the graph. Right, so you're finding this area here. What's the area of that shape again? That's a triangle, right? Oh yeah, find it quickly. Find back the area of that shape, right? Are you confused? Huh? You were here last week? That's the video.
It's one plus.
Oh, Antonio. Okay. Yeah, what the video, right?
Yeah.
Yeah. Right, so part 3, find the distance travel, use the area formula, right? Right, find the area of that shape there. Right. We have find the area quickly. Find the area. That's part 3, right? Find the base, find the height. What's the SI unit? Meters, right? Put the SI unit as well. Triangle, right? So that's meant to be based on the angle. Happy. Five to minus y. Right? Right, and the area is what? The area is half base by height. So here to here is the base. That's 60 minus 25, right? How much is that? So it's half by 35, and the height is here. The height is 12. How much is that? 210 meters. That's okay? Right, let's go again. Next one. Huh? No, they only ask for the third stage. Okay? So you don't have to add up everything, right? Suppose that asks for the whole journey. What you have to do? Suppose Joshua, they ask for the whole journey. What do I do? Find the area of everything, right? How you find the area of everything? You can find all three, or you can use wood formula to piece it on, right? All right, let's go again. That was page 114. Huh? Oh yeah, you're right. Then did you get that wrong? Oh yeah, write it fast. All right, next one. Just turn the page, right? 115. That's June 2010. What type of graph is this? What type of graph is this? Screen time, right? Answer ABC, and then we will go to the next one. Although after we do this one, we did this one already. All right. Try that, please. Again, it's a speed time graph, so you're working with number 2, number 2, number 3, number 5. Oh yeah, everybody try it. Call on some fresh people. I got a call on before. You go on and big on, very good. Huh? That's right. Take them. Right? Same thing again. Speed time graph again. Yeah. I try one. Yeah. Check and see. I think we did this last week. Check back and see. Yeah. Right. We did this one already, so I know in this one. We didn't do it last week?
Something like this.
Okay. All right. Do it fast. Find the maximum speed, number of seconds, and total distance traveled. Did this one? Oh, it's out. All right. Yeah, learn more. And we have 2025 to do. 2025 has the number 7 number. Oh, this number can be about 3. Somebody get to my favor and set back 2025. It's only group. Somebody just, yeah, paper 2. All right, let's go. Maximum speed. What's the maximum speed, Giovanni? What's the maximum speed from the graph? Look at the graph and look at the highest speed it reach. 12, but give them the SI unit, right? So the highest speed reaches right here. The highest speed reaches right here, 12 meters per second. The number of seconds when the speed is constant, right? So which part of the graph scenario the speed constant? The straight, well, the horizontal. Remember all those lines straight, right? How long is that? How much? 4 seconds. Very good. Right? How we getting the total distance traveled? How we getting the total distance traveled? Let us click on this one. Total distance traveled is what? What type of graph is that? How you find distance traveled on a speed time graph? Still on the board. On the board. Where the board is. How you find distance traveled on a speed time graph? What? Read number 3. Number 3, area under the graph, right? So you have to find the whole area to show. That's okay, Olia? And you have two options. The first option is what? The first option is trapezium rule, right? Or second option is split it up into two triangles and a rectangle. Okay, so those are three options. I will be using trapezium rule. So the formula is half the sum of the parallel sides, half the sum of the parallel sides multiplied by the height. Right, use any method you want and find the total area, please. And let's zoom in there for you, right? Hurry up. Find the total area, let's pass on to see what some people have. Any method you want. Triangle, rectangle, or trapezium. I prefer you to start practicing using trapezium, right? Somebody just stand about 25 minutes.
So she said,
Sorry. You're rough.
sorry.
Okay. So again, I kind of prefer to use your PDM formula, right? So it's half the sum of the parallel side. Parallel side is here and here. So that's half of 13 plus 4. You'll follow that, right? Parallel side and the two red sides there. The first one is 13 and the one on top is 4. Right? And the height is here. Right? The height is here. So the height is 12. Yeah. I bet you okay with that? So you have to learn to use your PDM rule, right? How much is that? 102? 102 meter. 102, right? That's making sure. Just go again. Right. If you check in the group, there's 20, right? There's one more here I want to hold on. I want to use 2025 as well. All right, how are showing this way? Any best I can do here, right? What kind of graph is this? Velocity time, right? See if we can answer the question here. Right, the most important thing is you have to figure out what type of graph it is. And then use the rules, right? Hurry up. There's one more part on the next slide, right? They want just write that down that please. They want the distance traveled in the first 25 seconds. That's the last part. Distance traveled in the first 25 seconds. Write it down so you're going to find it. Distance traveled in the first 25 seconds. By time we do 2025 now. Distance traveled by the car in the first 25 seconds, right? All right. So going back here, zooming in, do part 1, 2, and 3 from now. Right, you should be able to see both of it, right? Again, if you can't see, take a little pick and zoom in, right? This is 2025. Online, can you please send some answers? Was nothing in the group. Anybody else nothing in the group? Or any group, right? But yeah, I'm putting on a crash course list next week with that Google form. Find out if you're doing the crash course and sign up one time, right? This class is full already. Right, so we'll take anybody else to do who want to do it, right? Yeah. Question on the group? Take your time, look at the graph, and let's answer everything, right? Right, they're interested in stage 4. Oh, I like part two. Part two, I didn't think has a. What page it on is number 9, I think. Huh? Check number 8 and number 9. Take your time with part two. Part two was a little tricky. Always find acceleration on a velocity time graph again. Gradient, right? So you had to figure out which gradient is the biggest. Be careful. During stage 4, the car, I'm gonna rush. I know. I said, yeah. But let's get one more question on this. So far, we're doing speed time, right? Don't think use this. Right, ready? Let's pick on here. Pick on you. All right. Thanks, Brian. Brian, help. How's it now? Bradley, what is the car doing on stage 4? What is speed of traveling at? 45 in between, okay, I'll take that. So it's traveling at 45 meters per second. And the important part with an acceleration of what? 0 epsilon. Right? But here's the problem. The problem is how we do in part 2. How are we getting the maximum acceleration? Right? Can you tell me which stages the car is accelerated? Rihanna? During which stages the car accelerated? 1 and 3. What about 5? 5 is deceleration, right? Very good. So we don't know which one the answer is. So you have to work on both of them. Right? But since you all real good at math something, right? Anybody can just watch it and figure out which gradient is largest. Longer line. I'll write an explanation. Which one? What does gradient mean? Gradient means slope, right? So which of those lines looking like it's sloped the most? 3 is looking like it's sloped the most, right? Okay. So work out the gradient for 3. All right. Work out the gradient for 3. My advice is if you go to them just to convince yourself, right? Right? I just zoom in a little more for you there. Find the gradient. So just read off x1, y1, read off x2, y2. Well, the next one Oh, you have to find the gradient. Find the gradient there and tell me the acceleration. Please write the SI unit after it. There you go. Put it in both of them. Right. Go, man, go. I think both are cycle. That's so. Right, and remember you have to find the area, you have to find the distance traveled in the first what? 75, 45. What was part 3 earlier? Find the distance traveled in what? First 25. 20. Right, so let's see what you got for gradient. So if I read off underneath here, I am getting 25, 20. If I read off on top here, that is 35, 45. So the gradient is equal to 45 minus 20 all over 35 minus 20. Right, so that is 25 and 10, 2.5. Anybody get that? 2.5? Yeah. What's the SI units again? MS minus 2. Okay. So that is the gradient formula, right? And then Do part three. Do part three. Find the distance traveled in the first 25 seconds. Right here, 25, right? Find the distance traveled in the first 25 seconds. Read it off and find right, it's up to you. You can use the Bezier formula or you can put it up. Good. Hurry up, we'll work out that fast. Right? What we got the area. Right? I am using this. What shape is that? I should be them again, right? So to find the area here, I use it half the sum of the parallel sides. I got what's that? 10. Here is 10, and here is 25. 10 plus 25, and the height is 20. 250. Yeah, 250. Yeah. Just trying to get up. 250. No? Why? You know, find area. Huh? Okay, so the parallel sides and the height. Let's go again. Right, this one here might be a little problem. At the best help you. Oh, well, I can see it. I'm not taking a picture. Right, here what you can do, right? I want to zoom into the graph. Let's take a pick of what you have to find. Take a pick of the things I have to find, and then I'll zoom in to the graph.
Don't.
Right? And I'm zooming into the graph. What type of graph is this? You might can see it, but a distance time graph, right? That's okay. So we're using the distance time information, right? Part one. Right? You can take a picture of the graph if you need it. Part one, the time at which the athlete left the training camp. Right? So you'll recognize it's in hours, right? 4 o'clock, 5 o'clock, 6 o'clock, 7, 8. Right? We have to figure out what time he left the training camp. So we have to read this time all the way down here. We have to read that time down there, right? Think somewhere you got. Right. What you all got for the time there? Right. So it's looking like, right. This is 1, 2, 3. Right now, I just showing you how it's broken up. Right? And anybody figured out the time? 4:15. Right? Between 4 o'clock and 5 o'clock, how many blocks we have? 4 big blocks, right? Y'all seeing that? Sorry. 1 block here, 2 block here, 3 blocks here, 4. So therefore you break up the time into 4 equal parts. So 60 divided by 4 is how much? 15. Okay? So every big block, it's not that clear, but every big block is 15 minutes. So the time there is 4:15. Okay, I know you kind of have to count there, but right, those are the big blocks there. So the time is 4:15. Next one. Distance from the camp to the park. Distance from the camp to the park. So I think the park is up here. Hold on, huh? Let's just read what happened. So the diagram below shows the journey of an athlete running from the camp to the park and back to the camp. Right? So here is the camp. Here's the park. And here's back to camp. Okay. The question was distance from the camping park. Right, so you have to read off this. How much is that? Right? How much is that in? Yeah, you had to go all the way across. I'll draw a line for you. I'll draw a line. What's that? About 9, right? That's about 9 meters. So part 2 is 9 meters. The length of time now, the length of time he spent at the park. What are you looking for? Giovanni, what are you looking for? Length of time at the park, right? You're looking for this horizontal part there. How many blocks is that? What blocks it is? How much big blocks? 2 big blocks, right? So how long is that? 30 minutes, right? Half an hour. That's okay? 30 minutes, right? Right, I know the pick is not press or that's sorry. So the length of time at the park is this horizontal part here. And last part, the speed on the way back. How do you find speed on a distance time graph? Let me pick on somebody. What are you listening? Pick somebody new. They pick somebody new. How you define part 4? How you find the speed on a distance time graph? So we help out now. So the way back to the park is here, right? So the way back to the way back to camp is here. How you find the speed? The distance time graph. Okay, distance over time or what? Number 1. Gradient. Right? So you can find gradient or you can find distance over time. Same thing, right? No, on the way back to camp. Oh, wait, sorry. On the way to the park, wrong one. On the way to the park is here. Sorry. Right? On the way to the park is there. Sorry about that. Right? What's the total distance again? On the way to the park is how much? 9 meters, right? Now we have to figure out the time. Right? Because I know you're not seeing, I'm going to help you with the blocks. They're looking like 1 block, 2 blocks, 3 blocks, 4 blocks, 5 blocks, 6 blocks. Right? It looks like 6 blocks. So my question is, how long is 6 blocks, Hilario? How long is 6 blocks? How long is that? Hour and a half, right? Hour and a half. Okay. So divide distance by hour and a half. So 9 divided by 1.5. 9 divided by 1.5. How much? 6. So the answer is 6. What's the SI unit? Alex, what's the SI unit? What's that? What's the SI unit? Kilometers. That's it? Well, I'm wrong. The answer is kilometers per hour. All right, kilometers per hour. Yeah, you see that. See that somewhere.
I see it.
Kilometers per hour. All right. So that brings us to the end of time graph. Right? What's the most important thing in time graph, Christopher? We know put your hand for picking a little time. What's the most important thing in time graph? This, right? in time graph questions, you have to know these things here. Gradient of a distance time, what you will get, gradient of a velocity time, what the area under the graph is, and what is two line represent. That's okay? So you have to know these small things. Yeah, stick on me. Right, next week. And until video time. All right. So we are stuck class today. All right, everybody go on ahead. Come on, Tony. All right, online. You all can log out.